Yesterday we talked about the extrema always occurs at points called critical points. And critical points, say C on the interval, closed interval AB, are either where the derivative is equal to 0, implying that we have something like this. We've got some kind of curve where there's a point where we can draw a horizontal tangent. And horizontal tangents always have a slope of 0. So it has to be one of these three options if the derivative equals 0, or the derivative does not exist, which means there has to be some kind of bend in the graph, either a sharp bend, any kind of abrupt change in direction. And this is, of course, provided f of x is continuous. Because if it's not continuous, if there's a discontinuity, if there's a jump discontinuity, if there's an asymptote, if there's a break in the graph of any sort, then the derivative won't exist at that point either. But if f of x is continuous, critical points either occur where the slope is 0 or the slope does not exist, meaning there's a horizontal tangent or there's a sharp bend in the graph. And then there's also a secondary fact that says extremas which are our absolute min, max, or our, we'll just stick with that. Our extremas, the absolute minimum and maximums, only occur on an interval AB at either, number 1, the endpoints, A or B, the highest point in the entire interval and the lowest point on the entire interval either happens at the endpoints of the interval or it happens at some critical point in the interval. Or at a critical point, we'll call C, where the element C is an element of the interval A to B. And of course, there's some cases to this. The derivative at that point is 0, or the derivative at that point does not exist. Yes, C element of. Extremas, the highest point on an interval and the lowest point on an interval only occur either A at the endpoints. Okay, so either A and B are your highest and lowest points, lowest and highest points, or if you draw some kind of continuous curve in between there, as long as it's continuous, so if we were to draw something like this, that's a continuous curve on that interval A to B. Then, okay, in this example that I have drawn, the endpoints are not the highest values, but the highest values occur down here where the derivative, the lowest value occurs down here where the derivative would be equal to 0, and the highest value would occur at the top where the derivative does not exist. Does that make sense? Here's good. Okay. So, with that said, that gives us a method of finding the highest point and the lowest point of a function on a given interval. Okay? And two things that cause the derivative to not exist. So algebraically, what's the two things that cause algebraically for a function to not exist? division by 0 or the square root of a negative. Okay? So that gives us a rule to find if we want to know where the derivative equals 0, we just set it equal to 0. If we want to know where the derivative does not exist, then that means that there is either a division by 0 or a even root of a negative. You can't square root a negative, but you also can't fourth root a negative. You can't sixth root a negative. So any even root of a negative. Okay, and then so for example, 3 divided by 0 does not exist. Square root of negative 6 does not exist in the real number system. Square root of negative 6 is an imaginary number, not a real number. Okay, so here's an example. Find the absolute extrema of f of x equals x squared on the interval -2, 1. We're going to find the highest y value, we're going to find the lowest y value. We're going to find the highest y value, we're going to find the lowest y value. Extremas only occur at the endpoints or at critical points. So step 1 is we're going to look at the endpoints. What's the endpoints of our interval? So we have x equals -2. We've also got x equals 1. So our endpoints are -2 and 1. If we were to graph this, -2 would be the farthest thing on the left of the graph. 1 would be the farthest thing to the right of the graph. If we want to know the absolute extrema is the highest or the smallest y value. To know the highest or smallest y value, we've got to first just know the y values of all the individual points. How do we find the y values when x is -2? We just plug it into the equation. So we just take -2 and plug it in. -2 squared. So we get 4. F of 1 is 1 squared, which is equal to 1. So looking at this, we have one value that's bigger than another. Okay, so this 1 is definitely not the absolute extrema. Okay? But then we also need to check the critical points. So now we need to look at the critical points. Because an absolute extrema can either occur at the endpoints or at critical points, provided it's a continuous function. And x squared is a continuous function on the interval -2 to 1. So now we're going to look at the critical points. The critical points deal with where the derivative is either equal to 0 or the derivative does not exist. So before we can look at the critical points, we first have to find the derivative. What is the derivative? 2x. So we're going to look at the critical points. So we are going to look at the derivative. Critical points occur where the derivative is either equal to 0 or the derivative does not exist. 2x, does that have a division by 0 in it? No. Does it have a square root in it? No. So will 2x ever not exist? No. So the only case would be a critical point where 2x is equal to what? Critical points only occur where the derivative is equal to 0 or the derivative does not exist. Since there's no division by 0 and there's no square roots, we know the derivative will always exist. So the only other way critical points could occur is if the derivative is equal to 0. So we just take 2x and set it equal to 0. Solving that gives us x equals what? X equals 0. We divide the 2 over. 0 divided by 2 is 0. So, the absolute extrema either occurs at the endpoints, which are -2 and 1, or at the critical points, which is at 0. Is 0 between -2 and 1? Yes, so 0 is inside of our interval. So, since 0 is an element of -2 to 1, we need to figure out what is f of 0. If it doesn't fall in that interval, then it's not important at all, because we're only looking for the absolute extrema that's in this interval. So since it is in that interval, it becomes important for this problem, so we need to figure out what's its y value. All right. Are you interested in taking the American test? Yes. It will be next Friday during the 6th period. And then Mrs. McCarty wants me to give you the study guide. F of 0. If you want to know what f of 0 is, we just take 0 and plug it into what? The derivative or the original function? The original function. What's 0 squared? 0. The absolute extrema, the highest y value, the smallest y value, either occurs at an endpoint or it occurs at a critical point. So here's all of our y values. F of -2 is 4, f of 1 is 1, f of 0 is 0. We've identified our endpoints, we've identified our critical points, we've plugged them all into the function to figure out the y values. Now it's just identify the absolute extrema. Which one's the largest? 4. So this is our absolute max. This is our absolute max. And our minimum is 0. This is our absolute minimum. This should make sense because if we were to graph this, -2 squared is 4, -1 squared is 1, 0 squared is 0, and 1 squared is 1. So if we were to graph x squared on just this interval, if we were to graph this picture on just this interval from -2 to 1, it becomes very easy to look at the picture and say, hey, there's an absolute max, and it occurs at the point -2, 4. Is that what we got algebraically? Yes. And there's an absolute min at 0, 0, which we got algebraically. Okay, the whole point of this, guys, is if you don't have, at one point in time, we didn't have graphing calculators that would do all this for us, so using the derivative gave us an additional way to draw pictures without knowing what the graph looked like specifically. Okay, let's do this. Let's do another thing. Okay, let's do find the extrema of f of x equals 1 over x squared on the interval -2 to -1/2. Find the extrema of f of x equals 1 over x squared on the interval -1 or -2, (-1/2). Extremas always occur at the endpoints or at the critical points. The endpoints are x equals what? And x equals -1/2. To find extrema, the highest and the lowest value, we need to find out their y values. So we just take these and plug it into the original function. We take -2, we plug it into the original function. We get 1/4. -2 squared is 4, so it's 1/4. Plugging -1/2 in gives us 1/-1/2 squared, which is 1/1/4. Can't have a fraction over a fraction, so instead of writing it 1/1/1/4, or instead of writing it as 1/1/4, we're going to write it as 1 times 4/1, right? When you have a division by a fraction, you multiply the reciprocal. And what's 1 times 4/1? Just 4. Okay, so looking at the endpoints, we definitely know that f of -1/2 is larger than f of -2, but there's no way to know if 1/4 is the absolute smallest or if 4 is the absolute largest, because there may be critical points somewhere between these two where that happens also. So step 2 is to look at the critical points. And the critical points are where the derivative equals 0 or the derivative does not exist. So, in order to find the critical points, we've got to first find the derivative. We've got to find the derivative of 1/x squared. This is very similar to one of the problems that was on the test. You'd rewrite this as x to the what? -2. When you move something off the bottom, it changes the power to a negative. And then the derivative of this would be -2x to the -3. Because you'd bring down the -2 and you'd subtract 1 from -2. So the derivative is -2 over x cubed. Now to find the critical points. The critical points happen in 2 cases. It's where the derivative is equal to 0. Critical points happen where the derivative equals 0. So we're going to set this equal to 0. How do we get x cubed off the bottom? Multiply it over. X cubed cancel. 0 times anything is 0, so we get 0 equals -2. That's a false statement. There's no x's to solve for. What that means is there's no solution. The derivative will never equal 0. There's nothing to solve for. There's no x answer where the derivative is equal to 0. So that doesn't lead anywhere. But there's also critical points where the derivative does not exist. And we have 2 cases that cause us to not exist. You cannot divide by 0. You cannot square root a negative. Do we have a division in this problem? Yes. We cannot divide by a negative. That means x cubed cannot equal 0. Okay? So the derivative does not exist when x cubed equals 0. How do we get rid of a cube? You cube root. X equals the cubed root of 0, and any root of 0 is 0. The bottom cannot equal 0 because if it does, that means the derivative does not exist. So we set it equal to 0 so we can find out where that happens at. It happens at 0. So we have a critical point at x equals 0. But What interval are we interested in? We're interested between -2 and -1/2. Does 0 fall in that interval? No. 0 is not an element of -2 to -1/2. That means in context of this interval, this value is irrelevant. X equals 0 is irrelevant because it's not in the interval that we're interested in. So our only two possible options are the endpoints. And with that said, that means 1/4 is the what? This is the absolute min. And then the 4 is the absolute max. Do let's do f of x equals x to the 2/3 on the interval -2 to 3. Take 5 minutes to try that. Guys, one thing for the sake of this, real quick I'll show you. F of -2 would be -2 to the 2/3. I'm going to rewrite this as the cubed root of -2 squared. Because 2/3 can be written as the cubed root of the element squared. And the reason that's convenient is what's -2 squared? 4. So we're just going to leave it as the cubed root of 4. That way we don't have a decimal. Because the cubed root of 4 is a decimal. So rather than using the decimal, we're just going to leave it as the cubed root of 4. And then we'll do the same thing with 3. 3 to the 2/3 is actually the same as the cubed root of 3 squared, which is the cubed root of 9. And these are easy to compare because if you get the cubed root of 4 and the cubed root of 9, obviously the cubed root of 9 is higher. Okay? So rather than dealing with decimals, we can leave it like that. Going over the critical points, guys, we got to find the derivative. The derivative of this would be 2/3 x to the -1/3. Right? Bring down the power. X to that power -1, and 2/3 -1 is -1/3. And then this would get moved to the bottom to make it positive, so we can rewrite this as 2/3 cubed root of x. So, in doing that, critical points either occur where the derivative is equal to 0, or the derivative does not exist. So to find where the derivative equals 0, we set it equal to 0. Zero equals 2/3 cubed root of x. And how do we get the 3 cubed root of x off the bottom? Multiply across. Technically, guys, when you're trying to find out where the derivative is equal to 0, if it's the derivative of equals a fraction, you can actually just set the top equal to 0. Because the bottom is always going to multiply and go away. Does that make sense? So for a shortcut, you're always going to have to multiply this bottom over, which means the bottom is always going to disappear because you're multiplying by 0. So if you want to know where the derivative is equal to 0 and it's a fraction, you just set the top equal to 0. 0 equals 2, that never happens, so the derivative never equals 0. That never happens anywhere in the graph. But the derivative does not exist, that does happen. Cubed root of x. Can we take a cubed root of a negative? Does 3 negatives multiply to make a negative? Yeah, let's see. Square root of -4. That doesn't exist because -2 times -2 makes 4. The square root of -8 does not exist because 2 negatives make a positive. But the cubed root of negative 8, that equals negative 2. Because negative times negative times a negative makes a negative. So we can have cubed root of negatives. So the cubed root is not an issue, but there is an issue with the fact that we have a fraction. We can't divide by 0, which means 3 cubed root of x cannot equal 0. So if we find out where it does equal 0, then that tells us where a critical point is. So how do we move the 3 over? Divide 3 over. We have the cubed root of x equals 0. And to get the cubed root of x, to get rid of a cubed root, how do you get rid of a square root? What's the opposite of a square root? You square. So if you want to get rid of a cubed root, you cube it. You cube both sides. 0 times 0 times 0 is 0. Yeah, because the bottom can't be 0, because if it is 0, that means the derivative does not exist. So you just set the bottom equal to 0 to find out where that happens. Hey, does that make sense? So the only way that this would not exist is if the bottom was 0. So we set the bottom equal to 0 to see where that happens. So it happens at x equals 0. Is x equals 0 in the interval that we're interested in? Yes. 0 is an element of negative 2 to 3. Since it's an element of that interval, that means that it's a possible extrema, which means we need to figure out what is f of 0. We need to find out its y value. So we plug it into the original function, which is 0 to the 2/3, which is the cubed root of 0 squared, which is the cubed root of 0, because 0 squared is 0, and the cubed root of 0 is 0. So we've got 3 possible y values. We've got the cubed root of 4, we've got the cubed root of 9, and we've got 0. Which one's definitely the largest? Cubed root of 9. This is our absolute max. And then what's definitely the smallest? 0. So this is our absolute min.
Are we going to have to find like the local ones?
Well, the local min, same concept. Because the local minimums is that where the derivative is equal to 0 also. Okay. Yeah, let's take a look at this. Let's just take a look at this graph real quick. Grab my. If we take a look at the graph of this, we'll see why this is, or what this picture looks like. So if we go to Desmos, launch the calculator. If we type in x caret 2/3, there's the object that we're interested in. And what was the interval? Negative 2 to 3. So if we, I think it's we can add a restriction. I think it's using this notation. Negative 2 is less than x, which is less than 3. So that's the picture we're looking at. So we have our endpoint. It says negative 2, comma, undefined. What that means is the reason it says undefined is because I do not have an equal to. I don't know if I put an equal to if that'll work. Oh yeah, it will. Hey. Okay. Negative 2, comma, 1.587. This is 3, comma, 2.08. And then there's a critical point at 0, 0. If you type in the cubed root of 4, the cubed root of 4 is 1.587. If you type in the cubed root of 9, the cubed root of 9 is 2.08. Okay, and the way you would type that in the calculator is just, oh, here, we can just type it in this way. Cubed root of 4, 4 to the 1/3 power. And then we'll just do equals y. No, equals, there we go. 1.587. 1.587. Yep. And we change this to 9, the cube root of 9, we get 2.08, which is the endpoint, 3 comma 2.08. So that's the picture we're looking at. But we identify the absolute maximum and the absolute minimum without having a picture drawn for us. And this is where we will stop the notes. The assignment for tomorrow in class. What you'll be doing tomorrow in class is the following problems. On page 229, it's going to be problems 1, 3, 5, 9, and 10. All of these problems give you a graph. So you just look at the graph and answer the questions. Where's the absolute minimum max? There's no algebra for those. 21, 23, 25, 26, 27, 28. 29, guys, you're going to need to know the chain rule when you do the derivative. Okay? So 29 requires the chain rule. And then I'd like for you to try 37. It involves the chain rule and the product rule. Okay? We've done problems like 29 and 37 in terms of doing the chain rule, but it's not as basic as these other ones that I have listed. So this is the assignment to be done tomorrow in class. And then, like I said,